everyone, in this video, we will be solving quadratic inequalities in one variable. So we have an example here, x squared plus x minus 6 is less than 0. So we're supposed to determine the solution to this inequality, and we represent this solution in a number line. So the first step that we are going to do is to rewrite this into an equation form and solve for x. So if we were to do that over here, we are going to use the box and diamond to solve for this. So that is x squared plus x minus 6. Again, we rewrite it to its we rewrite it as an equation that is equal to 0. And then we have to use the box and diamond to figure out what are the factors for this. So there's going to be a factor for this that would be equal to 0. So to find that factor, again, we're going to use the box and diamond for this. I'm going to show the box and diamond on the side. So this is a negative 6x squared, and that's an x at the bottom. So the factors that we have here would be 3x and negative 2x. So then we are going to write the box in order to find the factors. That would be, we write the first one here, that's x squared, the last term, which is negative 6, and then the red factors that we got, 3x and negative 2x. So then we can find the factors from here. That would be x and x. So I'm going to write x and x here, and then this is a negative 2, and this is a 3. So the factors are x plus 3, and then we have x minus 2 equals 0. Using the zero product property to find the solution, that would be x plus 3 equals 0. So minus 3 from both sides, so minus 3 and minus 3. So we can cross the minus 3 out. So we're left with x equals to negative 3. And then the other one right here is x minus 2 equals 0. So plus 2 and plus 2 to both sides. So then we have x is equal to positive 2. So these are the solution to this equation. Now this 2 points that we have here, we are going to name them as the boundary points of our inequality. So these are our boundary points. So if we are to draw the number line, because it says here we're supposed to represent the solution in a number line. So I'm going to draw the number line here. So this is where the 0 is in the middle. So that's 0. So I go ahead and go, that's all the way to negative 3. So 1, 2, 3, 4. So negative 1, negative 2, negative 3, negative 4. Then we have 1, 2, 3, 4. So that's 1, 2, 3, and 4. Now, it says that our boundary points are x is equal to negative 3. So I'm going to go ahead and that's where is that negative 3 is. It's going to be right here. Since this is a less than, there's no bar underneath. So this is going to be an open circle on x is negative 3. So I'm just going to draw an open circle there. And then the other one is on 2. And it's going to be, again, an open circle on positive 2. So these are we consider these two as the boundary points for this inequality. Now, we have 3 regions for this. The left region, the left from this boundary points, the middle region, and then the right region. So we're going to be testing each of these regions, which of this is true. If we plug in values. So let's see which of these 3 regions would be the solution. So is it the left region? Is it the middle region? Or is it the right region? So to do that, we are going to use some test points. So we're going to have some test points here. So let's test anything that is to the left of negative 3. So we're going to test, you can test negative 5, negative 6, but for now, let's just test negative 4. So x is equal to negative 4. So I'm going to use the original equation. I'm going to rewrite it. So that would be x squared plus x minus 6 less than 0. Now this time around, we plug in negative 4 to the x because we're testing if negative 4 is a solution or not a solution to this inequality. So to do that, we are going to, again, the trick to do that is to change the letter into a parentheses first. and then plug in values after that. So here I'm gonna put in the -4 and then the -4 right here. So -4 times -4 is 16, and then that's a -4 minus 6. Is that less than 0? So that would be 16 minus 4 minus 6 is 6, less than 0. This is false because 6 is greater than 0. So this is false. So that means this left region is not a solution because it came out to be false. Now we are testing the one in the middle. So I'll just use a different color of pen for the middle here. So we're testing x equals 0. Again, you can test any points within this middle region. You can test x equals -2, -1, or +1. I'll just use 0 so it's faster. So let's test x is equal to 0. So from here, we use the same equation. That would be x squared plus x minus 6 is less than 0. So then we are going to plug in the 0 to the x because we're testing it. So I'm just going to put change the letters into a parentheses first before I put in the values. So here we are putting 0 to the x. So that's 0, that's 0. So 0 squared plus 0 is just 0. So we're left with -6 is less than 0. Is -6 less than 0? Yes, it is. So this is true. Now let's have the other region that we have here, to the right of this boundary point. So let's use a different color marker for this. So that would be, again, we can test 3, 4, 5, 100, whatever it is, as long as it's greater than 2. So our test point, let's just pick 3. So our test point, our number that we're going to be testing is x equals 3. So then I'll write the equation again. That's x squared plus x minus 6 is less than 0. So then I'm going to change the x into a parentheses. That's a squared is less than 0. And then we put in the 3 here. So that's a 3. That's a 3. So 3 squared is 9. So that's going to be 9 plus 3 minus 6 is less than 0. So this would be 6. So 9 plus 3 is 12. 12 minus 6 is 6. So 6 is less than 0. Is this true or is this false? This is false because 6 is greater than 0. So that means the side that is the true side is the solution. So that means this side right here in the middle, anything that is in the middle between or in between this this circle right here, in between -3 and 2 are the solution to this inequality. So if we are going to change this to inequality notation, we can write the solution to this inequality is x is greater than -3. So anything that is greater than -3 but less than 2. So this is the solution to this inequality. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. It's pretty much the same thing. We do the same step, but for this problem right here, we're gonna make the right side equal to 0. We can do that by adding 2 to both sides. So that's a +2 and +2 here. So we are left with 2x squared plus 7x minus 15 is greater than or equal to 0. And then we are going to use this equation. Again, we change it to an equation. This inequality, we're going to change it to an equation, and then we solve for x. So in this problem right here, we have 2x squared plus 7x minus 15 equals 0. So we need to find the factors for this equation right here. Okay, so to do that, we are going to use the box and diamond. That would be -30x squared, and that's a 7x. So the factors for this are 10x and negative 3x. And then we're ready to use the box or the area model to find the factors. So we're going to write here the first term, that's 2x squared. And then we have a negative 15 here. And then the red factors that we got, I'm just going to write 10x here. And this is negative 3x. So that means the factors are x and 2x. That means that's 2x squared. This would be a negative 3. And this would be a 5. And so we got a negative 15. So the factors are x plus 5 and then 2x minus 3. So use the zero product property. This would be x plus 5 equals 0. So minus 5 and minus 5. So then the x is negative 5. So this is our first boundary points. But first of the two boundary points. So the other one is 2x minus 3 equals 0. So plus 3 and plus 3 from both sides. So we're left with 2x is equals to 3 divided by 2 divided by 2. So then our x is 3 halves or 1.5. So this is the second boundary points. Again, we call these ones as our boundary points for our inequality. Okay, so what are we going to do now is we are going to draw the number line, and then we put in those boundary points. So this is the number line right here. So we're going to have the 0 here. So that's a 0. Then we go all the way to negative 1, negative 2, 3, 4, 5, 6. So it's negative 1, negative 2, 3, 4, 5, and 6. So that would be a 1, 2, and 3. So that's 1, 2, and 3. So the boundary points are x is negative 5. So it's negative 5 is going to be here. Now I am using a closed circle since there is a bar underneath. And then we have x is equal to 1.5. So 1.5 is in between. So I am going to use again a closed circle because there's a bar underneath. And let's approximate this to be 3 halves. So we remember, so I'd like to make a note here. Like a little note on this side. So if we get a greater than or equal to, or we get a less than or equal to, we're going to use a solid circle. Now, if we have a greater than or just less than, there's no bar underneath, we are going to use an open circle. So I will put this up here. So this little note. So we have a guide on in determining the solution to an inequality. Since there is a bar underneath, we're going to use a closed circle. So that's why we had a closed circle here. But in the first example, I used an open circle because there was no bar underneath the inequality sign. Okay, so there are 3 regions again. So we have the left region, the middle, and the right region of this inequality. So we can use 6, so we can test our test points. Let's just use 6 for the left region here. So that would be, we use the original equation over there. So that would be 2, then parentheses squared plus 7 parentheses negative 15. Is that greater than or equal to 0? Again, the numbers that we're, the test, the point that we're testing is 6. So I'm going to put in 6 to each of the parentheses here. So, oops, this is supposed to be negative 6. So this is supposed to be negative 6 right here. So then this is a negative 6 and a negative 6. So negative 6 is 36 times 2 is a 72. And then minus 7 times negative 6 is 42. And then minus 15 is greater than equal to 0. So if we subtract these 3 numbers together, this would equal to 15. That's 15. And then greater than equal to 0. So 15 is greater than equal to 0. That is true. Okay, now let's find the one in the middle. We will test the zeros. We're looking at the middle region right now. So we are testing, so I'm going to test x is equal to 0. So we use the same equation over there. So 2 times and then squared plus 7 times minus 15 is greater than equal to 0. We're testing it. Again, our test point is 0, then we put 0 here. So this comes out as 0 plus 0 minus 15 is greater than equal to 0. So is negative 15 greater than or equal to 0? No, this is false. So that means the middle is not the solution. Now let's test the right region. So that is anything that is bigger than 3/2. So let's use 2 as our test point. So that would be our test point is let's just say x is equal to 3. Again, you can use 2, 3, 4, 5. You can do other numbers bigger than 3. That should be fine. So we use the equation again, so that would mean inequality over there. So that would be 2 parentheses squared plus 7 parentheses minus 15 is greater than equal to 0. So our number here would be a 3 here, and that's a 3. So 3 squared is 9 times 2 is 18. And then that's a 21 minus 15 is greater than equal to 0. So this would be 24 is greater than equal to 0. Yes, so this is true. So that means our solution is the left region and the right region. So anything bigger than 3/2 and anything less than -5 is the solution. So when we want to write the solution right here, it would be that is x is less than or equal to -5 union, and the other one going to the right is x is greater than or equal to 3/2. So this is the solution to this inequality. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!